Hi, I'm Ahmed Daud, and in this session, we are going to see logistic regression provided by Scikit. So, in the last session, we have discussed how logistic regression can be trained, and we have discussed that logistic regression has different cost function as compared to our regression model like linear regression have. And we also have discussed the reasons behind that. So the today's session, the aim of this session is to have a look on the logistic regression provided by sklearn and their parameters, their attributes and their methods that we can directly import from the sklearn or we can use. We are not going to do some or going to solve some problem statement regarding classification, but here just aim to explore that module. One more important aspect is that till now we have discussed binary or we have considered just only binary classification uh, problems, or you can say scenarios. But here there are some parameters that also deal with the multi-class classification. So if you will not get an idea about them, so don't worry, we will discuss it also later. So first of all, this is sklearn.linear model.logistic regression. Parameter first, there also parameter penalty L1, L2, elastic net, none. Four type of values that penalty parameter can take. So what it actually do in that way that if you want to add some penalty, you want to penalize your model by some L1, by L2, by elastic net. I will tell you what is elastic net. Or you want your model without any penalty, then you can mention in that parameter. Okay, so what is elastic net? Elastic net is both L1, L2 penalty terms are added in the case of elastic net. It means that we can also specify that how much we want L1, how much we want L2. Okay, so for that, there is a parameter here, L1 ratio. When we have mentioned here elastic net in that penalty parameter, if we have passed the value elastic net, then we have to also mention L1 ratio. The elastic net mixing parameter with this L1 ratio has, uh, you can say, a range between 0 to 1. Okay, if I will zoom in, you can see clearly. Okay, so only used if penalty that I have told you that if we have mentioned that we want to use penalty is equal elastic net, then setting L1 ratio is equal to 0 means we want to use penalty L2. If we will make L1 ratio equal to 1, it means we are interested into penalty 1. But we will not actually do that. We will not mention L1 ratio is equal to 0 or L1 ratio is equal to 1, because if we want to use L1 or L2, we can mention by ourselves also. But if we want a combination of penalty 1 or penalty 2, then we can pass any value here and it will give you a ratio. How much uh, percentage of L1 penalty you want to use and how much percentage of L2 penalty you want to use, you can mention here. Okay, so here they are also saying for 0 to 1, the penalty is a combination of L1 and L2. Okay, so by using that sklearn, you can penalize your model by just passing the values in the penalty parameter. I have told you that the when we are doing some or building our concepts and we are discussing some maths. So I told you multiple times that don't need to remember everything, because everything is available in the libraries, in the modules. Just you have to import. But before importing, you have some concepts how these usually or these terms are actually and how it works, how L1 works. L1 is L1 norm. It add some penalty in the cost function to penalize your weights. Okay, we have discussed these penalties a lot in detail when we are doing linear regression in the sessions of lasso regression and ridge regression. Okay, anyhow, here another parameter, dual. Don't worry about this dual. Actually in mathematics, or mathematical optimization theory, there is a concept of duality principle. Okay, and, according to that concept, that you can you can view your problem from two angles. Okay, from this angle or from the other angle also. The one angle they usually call that, in which way we are actually visualizing or analyzing our problems, we they call that as a primer formulation. Okay, and there is also a way of analyzing your problem can be a dual. So that's why they call it as a duality principle, and there are also a lot of maths behind it. I'm not going to in the detail of that. And if you are really interested in, you can explore that duality principle. You can search, let's say, duality principle. Yeah. There are a lot of material. If you want to just give a want a just concept, you can explore from the Wikipedia also. Okay, you can see here it's a duality principle, and it's a principle that optimization problems is that like we have our cost function and we want to just that type of parameters in which our cost function will be minimum. Okay, there can multiple feasible solutions, but we want best possible solution which will give best fit model and will give minimum cost, minimum error, okay, minimum loss. So that type of problem usually fall under the optimization problems, in which we are optimizing and we are finding best solution out of the all available solutions. So duality principle is the principle that optimization problems may be viewed from either of two perspectives. Perspective can be the primal problem or the other can be dual problem. Okay, you can explore, but it's not really necessary for now. Okay, so if in the case of dual, there can be two values can be in that dual parameter. So, or in the form of true or false. If by default it is false, and if you will make it true, it will become that you are interested in duality uh, to solve your optimization problem by duality principle. Okay, so dual formulation is only implemented for L2 penalty with linear solver prefer dual is false when n samples. And they are also telling you that if n samples greater than, like your number of samples are more than the number of features that usually we have in our data sets. So then it is preference that you should use dual is equal to false. Okay, but sometimes we will discuss these type of parameters that are in our daily routine use. Some parameters have some core mathematics behind it. Okay, we are not going to in detail of that. In the field when we are doing some solving some problems in some practical field, everyone have not all the concepts perfectly. Okay, there is how we can, and then how we can choose what type of parameter values you should have. Sometimes we are using that type of technique, like we are comparing scores. Let's say if you are not familiar with L1 and L2 penalty, and the other way is that you will train a model which will have L1 penalty, and you will train another model which will have L2 penalty. Then compare the scores of both models, which will give you best score. Then you will see that this penalty is good. Okay, you don't know what is math behind it. Okay, sometimes we are using that approach also. But having concepts is also really important and is really necessary because when we have a large number of parameters and a lot of ranges can come in the each parameter value, then there can be become a if we are not familiar with all the parameters or with like some strong parameters like the penalty and the max iteration and tolerance that we will have here also, like this tolerance and max iteration, these type of parameters, if we are not familiar with these type of parameters, it have very large number of ranges. Then if we will apply that type of approach, on the basis of score we will judge which parameter is good, then there will be thousands of combinations of parameter will become, and we will train thousands of, sometimes hundred thousands of models, and it will be very very time inefficient, and a lot of computation will need. So we should have some concepts for the parameters that are really more and more important, and for which parameter that are not much important, we will use the another approach, that we will check if it is giving good score on that value, or on that value, on which value it is giving us a good score, we will select that as our parameter value. Anyhow, come back. We are discussing dual, and after that, I want to discuss here the solver. Okay, so what exactly solver means? Solver, I have also discussed in the case of rich regularization, yeah, rich regression provided by Scikit-Learn. Here will be solver. Yeah, there are multiple solvers. What actually the concept of solvers are actually algorithms, like we have discussed in the case of linear regression, that the optimization problem, the problem of finding best parameter values, having some cost function, what approach can we can use? One approach in the case of linear regression, we have discussed that one approach can be of closed form solution, okay, normal equation that we have used. Another approach we have seen gradient descent, that we also have discussed in the case of logistic regression. So these are the most common approaches, but there are some also other algorithms that can also solve the problem of our optimization problem, can find best parameter values for us, like here the Newton CG, LBFGS, liblinear, SAG, SAGA. So SAG, SAGA, these are actually gradient descent. SAG means stochastic average gradient descent, okay? And SAGA, stochastic average gradient acceleration method. It's an extension of SAG. So what is SAG? Okay, I will tell you. Okay, so here we were discussing gradient descent in the case of linear regression when we were discussing. So gradient descent can be of multiple types. Okay, uh, that we have discussed. Uh, it was a batch gradient descent. Okay, it was a batch gradient descent. If I will write here, it was the batch gradient descent. Okay, what exactly means by batch? It means when we are here, we have to first initialize our parameters. Okay, if I will use another pen. Okay, so okay, then we have to calculate the partial derivatives of cost function with respect to each parameter. Okay, when we are calculating partial derivatives, we have also calculated here partial derivatives, these ones. Okay, here this is the our sum of squared error, and we are taking partial derivatives of that. Here you have seen that we are summing up all the values, we are summing all the errors. Okay, in the case of batch gradient, each time we will do iteration, we will use all the data points. But what actually stochastic gradient descent tells us, stochastic gradient descent, what actually this tells us, this says that just use one value, one one sample in one iteration. Okay, here we are using all the, like here you will see that we are summing up all the errors, we are summing here all the data points. Here you can see there is sigma involved. Okay, but instead stochastic gradient descent, usually we have SGD, tells that just use one sample at in each iteration. Okay, so this is SGD. So stochastic average gradient descent. Okay, this is the parameter value that we have here. It's actually the you can say it's similar as the stochastic gradient descent, stochastic average gradient descent, SAG. Sorry, here it will be G. Okay, so we can use that solver also. It is fast, and there are a lot of characteristics this algorithm also have. Some pros and some cons, like others also have. And there is also another extension of SAG, which is uh, here I will make as stochastic average gradient descent acceleration. It's an extension of SAG, acceleration method. We can say acceleration method. So SAGA. This can also be another solver. Okay, come back here. I am discussing that we can have multiple algorithms to solve our or to use in our optimization problem. We have discussed gradient descent and it's widely used. There is some other methods like Newton CG, LBFGS, linear, SAG, SAGA. SAG and SAGA are you can consider it as a gradient descent. Okay, so here they also have mentioned all the, okay, so here you can say in the case of here they have mentioned that which solver is best for which condition. Okay, and for which parameter value. If here they are saying the choice of algorithm depends also on the penalty. So if you are choosing Newton CG as a solver, then you can use penalty value L2 and L or without penalty. Okay, if you cannot use an L1 penalty here. Okay, in the if you are using solver Newton CG, the when you are doing that, it will give you a warning. Okay, it will not solve or give you some error. In the case of LBFGS, you can use only again L2 and without some penalty. You cannot use L1 penalty. In the case of linear, you can use L1 and L2 penalty, but you must have to use some penalty. Without the penalty, you cannot use linear. SAG also cannot use L1 penalty, and in the case of SAGA, you can use all type of penalties. Elastic net, it's a combination of L1 and L2. Simple L1, simple L2, and without penalty, you can use uh, uh, without penalty, you can solve your optimization problem, or you can find your best parameters by using, and your solver will be stochastic average gradient acceleration method. Okay, so these are the solvers. If we will go, yeah. If we will go here like user guide of sklearn, and they also have mentioned here, most probably, yeah, this is this table. Okay, no need to remember that table, but it has mentioned all the cases where in which with which parameter values we can use which uh, solvers. Okay, so regarding multinomial and OVR, multinomial and OVR, if I will discuss it here. Yeah, multi-class. If we are dealing with multi-class case, okay, there can be two schemes that we can use. One is OVR and one is multinomial. OVR we usually call as one versus rest, and multinomial is that it's also named a multinomial. And if we want to, we will make that parameter auto, then this parameter or this class will detect, or this module of sklearn will detect by itself which which value should be for the multi-class case. Okay, depends upon the which solver we are using, which type of data set is, it will select automatically the best parameter value for us. If we will select auto, and default is always auto. Okay, so one major difference is OVR use the same type of cost function that we have discussed, log loss. Okay, the function that we have discussed, log loss, it's also called cross entropy for the binary problems. Okay, for binary classification. But in the case of multinomial, it uses a cross entropy, but for the multi-class, you can say, for the multi-class problems. Okay, so this we will discuss in the detail later. But for now, you can consider that there can be two options for the multi-class. Okay, for simplicity. Okay. So here they have mentioned all the options here, with which penalty, with which multiple multi-class value you can choose, use which solver. Let's say if you have selected multi-class as a multinomial value for the multi-class multinomial, and you have selected L2 penalty, then you can use LBFGS, Newton CG, SAG, SAGA, any of the four solvers. Okay, but you cannot use linear here. Okay, so in the further, if you are using OVR plus L2 penalty, then you can use any of the solver. Okay, this table you can use when you are doing some hyper tuning of your logistic regression, and you are figuring out which parameter value should be good for which parameter values should be for your model. Then you can see that table, and it has given all you the limitations and the accessibility of the solvers. Okay, where where and in which case you can use that solver. Okay, I'll have some, let's say, the faster for large data sets. These SG and SAGs, the gradient descents are faster for large data set. If you have very large data set, you can use that solvers. Robust to unscaled data sets. If you have not scaled your data set, then you can use uh, all the solvers except the gradient descent solvers, these solvers. Okay, so here penalize the intercept. Then in the case of linear is can be used, other and other cannot be a good case, cannot be used here if you are penalizing your intercept. And there, so I mentioned it's bad. Okay, so this table you can read that table, uh, or you can explore and use the multiple values, and you can import a logistic regression class from the sklearn, and you can test your or you can explore that by by giving different values to your logistic regression. Okay, come back here. I am telling you the first one here, penalty. Okay, so penalty, which type of penalties are provided here by this sklearn here? L1, L2 elastic net, dual. Dual can be used, dual, I have told you it's a duality principle, and it's really not important to go in the maths of duality principle. Okay, the concept I told you here. Dual formulation, here they also mentioned dual formulation is only implemented for the L2 penalty with linear solver. Okay, you cannot use without that scenario. If you are using another solver, it will not work. Okay, you can use only dual formulation, or dual is equal to true is only implemented for when you have penalty is equal to L2 and solver is equal to linear. Okay, Now tolerance, or tolerance when you are iterating your process of gradient descent, let's say. So you can also mention tolerance for the stopping criteria. Okay, here by default it's at 10 raised to power minus 4. Here another parameter C. Maybe some of you have question in your mind that when we are adding our penalty in our cost function, we have discussed a parameter also with our penalties, like alpha or lambda. We have given these names. Alpha has given by the ridge regularization. Like this is the cost function plus alpha into the L2 penalty, like here in this case. So how much we want L2 penalty to add, okay? But in this case, logistic regression, there is no alpha parameter value here. Instead, there is a C parameter here. You can use C. C is the inverse of regularization strength. How much smaller value of C you will use, the more strength of regularization you are using. Okay. So it's inverse of alpha, you can say. Inverse of regularization strength must be positive, and like in sport vector machines, it's also another supervised machine learning algorithms. So smaller values specify stronger strength. Here you can see smaller values of C means you are using higher value of alpha, you can say. Okay, so after that, fit intercept. So fit intercept, as in the case of linear regressions, we have we want intercept or not. Okay, so it's the same parameter. If you will make it a false, it will be that you are not interested in the equation of model in which the intercept is present. Then you can also scale your intercept scaling. Okay, you should read that documentation. And anyhow, here this intercept scaling useful only when solver you are using liblinear, and your fit intercept is equal to true. Of course, when you have mentioned fit intercept is equal to true, then you can scale your intercept. So in this case, x become is a synthetic feature with a constant value, to lessen the factor. Okay, so I will tell you here. Okay, so what will be the intercept scaling? Intercept scaling. The concept of intercept scaling is simply that you want to scale your intercept. You want to make your value of intercept higher or low. Okay, you want to scale your intercept. How it works actually? Let's say you have just let's say you have this data set in which you have age as your independent variable and bound insurance your dependent variable. Okay, and your equation will be like this: probability 1 over 1 plus e raised to power minus m into h, you can say here, into h plus some c, some intercept. Okay, now you want to scale that intercept. Okay, you want to make let's say you want to make this c higher value. Okay, you want to make it larger as compared to natural value of c. How you can do this intercept scaling? How it can work? It what it will do, if you will mention that intercept scaling is equal to 2. Okay, how it will work? It will add another column here. Let's say another column, let's say intercept scaled, and two values, constant values, will be in the whole column. Okay, and this will be treated as an independent variable. When this will be treated as an independent variable, you will have equation like this: 1 plus e raised to power minus m into age plus, let's say this is m1, this is m2 into uh, intercept scaled plus the intercept that you have by default here. Okay, now this whole term, this whole term will become my intercept, because it's it you have added uh, constant column here. So that's why this IS, this intercept, this value, these are our values are will be constants. So when you will train your model, you will also get some weight for that or some coefficient for that. And actually, this is constant value. And when you will multiply, let's say you have find out, yeah, M2 best parameter is 0 point, let's say 5. Okay, now your intercept will be 0 and C you have find 4. Now your actual, or you can say, mm, and I will mention here M1 you have find out, let's say you have find out M1 as a, like 1.2, let's say. Okay, now your equation actually becomes in this way, like this: P cap is equal to 1 plus E raised to power minus M1, which is 1.2, into age, whatever value of age, plus intercept. Your intercept will become 0.5 into 2, this 2, plus 4, it will be 1 plus 4 equal to 5, it will become 5. Okay, if you have used intercept scaling parameter and pass the value is equal to. Okay, in this way, by default, your intercept value, if you will not use intercept scaling, you have not used that. Your according to these parameter values, your equation will be like this: P cap is equal to 1 over 1 plus E raised to power minus 1.2 into H, plus some plus 4. Okay, now you have seen that this is without intercept scaling and this is with intercept scaling. So you have scale, or you have make your intercept value larger. Okay, you have scaled your intercept value. In this way, this parameter works. It will add some constant uh, value with each instance, and then you will have some weights also for that intercept scale value, and overall it will scale your, it can scale your intercept. Okay, in this way it actually work, intercept scaling. Okay, come back to our session. Okay, intercept scaling. Now, they also have mentioned that if you use synthetic feature weight, that our weight was M2, like the weight for the new feature intercept scale. Okay, M2, let's say, in the case of this is a synthetic feature weight. Yeah, this one. We use, and this is synthetic feature weight. Okay, for the column, for this column, the weight for this column, it's a synthetic feature weight. They are mentioning here that if you want to like a synthetic feature weight is, if you have used some penalty L1 and L2, it will also penalize your weight M2. Okay, and if you want the to lessen the effect of regularization on your synthetic feature weight, you can use higher value of intercept scaling. Okay, it's simple that if you are using some penalty also, and penalty will decrease your M2 value, let's say from 0.5 to it can make it to 0.4 or 0.3. So to balance your value that your intercept, let's say here, if I will show you, let's say if you're using some penalty, your value will be M2 is equal to 0. Let's say 0.3. Okay, and you are interested that your scale value, your intercept should be 5, then here you can use this value as larger. Let's say instead of 2 you can use here for uh, for 1 2, yeah, about, let's say you can use here 3 value. Okay, it will become, when you will multiply, it will be 3 into 0.3, it will become 0.9, approximately 1, and your output 4 plus 1 is again equal to 5. Okay, but just these statement. Okay, now you also got an idea that these are not rocket science behind each parameter. These are the same that we have discussed till now. the same base concepts are the same. Okay, just you have to read the documentation carefully, that what actually they are saying. And they also mentioned that useful only when you are using solver lib linear. Okay. Okay, so in this way you can also scale your intercept. Till now we have discussed penalty parameter, dual. Okay, just uh, you can say a little bit about duality principle, tolerance, C, which is inverse of regularization strength, fit intercept, intercept scaling. So in the to make the session uh, like smaller, I will discuss this later next parameters in the next session. Okay, from the class guide. So for now, thank you.